All right, guys. So in this one, I'm recording this in a little bit of a different way, but I'm going to go over the 3.1.3 practice worksheet. So this is one of those ungraded practice worksheets that I like to go over with you on these videos to kind of clarify things before you take the corresponding quiz or do that activity that's linked to this. So on this one, the first set of questions, A through E, we're going to use our t-table, which I have right over here. I'm going to use my t-table to find the critical t-values. Those are our t-stars needed for each of the following. So let me zoom in a little bit here. Doop, 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 doop. All right. So the first one, we need to find the critical t-value or the t-star for a 99% confidence interval based on a sample size of 30. Okay. So remember, when we're using our t-table, I need to know my DF, my degrees of freedom, as well as the upper tail probability or the area under the upper half of the tail. So let's figure out what those are. The first one, the easy one, is degrees of freedom. To get the degrees of freedom, we're just going to take our sample size, which is 30, and subtract 1. So the degrees of freedom is 29. And then we need to figure out our tail value. So if I want 99% of the data centered here, so between here and here is 99% of the data, 0.99, then that means that these two tails here and here have to add up to 0.01. And they have to be the same size on either end. So if I take that 0.01 and divide it by 2, I get 0.005. 0.005. So I can double check this, add it all together. 0.005 plus 0.99 plus 0.005 is 1. So the area, the tail area or the tail probability is 0.005. That's 100% minus 99 and then divided by 2. So now that I have the two numbers that I need, I can go ahead and grab my table and find this number. So we're looking for a sample size of 30, means degrees of freedom 29 down here. And let's see, our area was 0.005. So I'll zoom out. 0.005 is right here. And go down to where they meet. I get a critical t-value of 2.756. 2.756. So I'll write that here. This for this part A, T star is 2. What did I say? Lost my train of thought already. 9905, 2.756. There we go. So I can then use this critical t value with my sample mean and sample standard deviation to find my confidence interval I need. But we don't have to do that step here. Okay, next one. Now we're looking at a 95% confidence interval based on a sample size of 15. So if the sample size is 15, that means our degrees of freedom is 1 minus that, 14. And our area, again, I can consider what does this shape look like if I have 0.95 here, then our two tails here and here have to equal 0.05. And they're going to be the same, so I divide that by 2. 0.05 divided by 2 is 0.025. 0.025 on either end. So my tail probability or my tail area is 0.025. So that's all I need. I can now grab out my table and look up those numbers. So we're looking at a sample size of 15, so degrees of freedom 14, and a tail area of 0.025, which is here. 0.0, oops, that's too far. 0.025 is there, right there. 0.025, 14 degrees of freedom. Our T star or our critical T value is 2.145. 2.145. Okay. Next, Again, we're looking at another 95% confidence interval, which means my tail area for part C is going to be the same as the tail area was for part B, which was 0.025. My degrees of freedom in this case, though, is 25 minus 1, or 24. Remember, with t-distributions, there are multiple t-distributions. Each sample size produces a different t-distribution. So this is the t-distribution that has degrees of freedom 24. All right, so now I have everything that I need. Go to my table, look at degrees of freedom 24, which is down here, and tail area 0.025 up here. Find where they meet. The critical t-value is 2.064. 2.064. Two more. Part D is a 99% confidence interval, so it's going to have the same tail area as part A, which was 0.005. But my degrees of freedom for part D is 18 minus 1, which is 17. So those are my two numbers, 17 and 0.005. Look them up on your table. 17.005, which meet here at 2.898. So our critical t-value is 2.898. Keep forgetting my equal signs for some reason. Those are equal signs. Equal. There we go. And last one. Now we're looking at a 90% confidence interval, which I have not done yet. So let's think about what their tail probability is. Let's see, 90% from 100%, that leaves with 10% left. So 100% minus 90% is 10%. Divided into two equal tails is 5%, or 0.05. Okay, so I can think of that again visually if you prefer. Here's 90%. These two tails have to be the same, and everything has to add up to 1 or 100%. So these two have to add up to 0.1, 10%, and they have to be the same. Half of 0.1 or half of 10% is 5%, 0.05. So our tail probability or our tail area is 0.05, not the same as it was in the last one. There's one less zero here. But our degrees of freedom is going to be 23 minus 1, or 22. So find our last critical t-value. Look up 22 and 0.05. Here is 22. Here is 0.05. And they meet here at 1.717. So there we go. There's our last critical t-value for a 90% confidence interval based on a sample of 23. All right, now let's go ahead and we're going to get our graphing calculator. I have one somewhere around here. And it says find the necessary critical t-value for each of the following. Okay, so we're doing the same thing we were doing in part 1, but now we're going to use our calculator instead of our table. Honestly, the table is really not that hard to use, but it is nice to know how to do it on your calculator anyways. So for mine, I'm going to go to my distributions menu and choose the inverse t option here. Okay, so I'll do this way, and then if you don't have this option, I'll do the second half of these questions using the t interval option instead. So for inverse t, I'll go ahead and hit enter there. It says, what's the area? And again, with the area here, I need to put in the tail area, just like we did up in number 1. We did calculate already here that for a 95% confidence interval with any sample size, we're looking at an area, a tail area of 0.025. So I can put 0.025 into my calculator here for the area, But remember, in your inverse t option in your calculator, it gives you the opposite tail. Instead of giving you the upper tail, it gives you the lower tail, which means the t star I'm going to get out of here is going to be negative, but it really doesn't matter. The negative t star is the same as the positive t star. They're opposites of each other. And when we do a confidence interval, we're going to add and subtract anyways. So it doesn't matter too much. You can just write the positive equivalent for this activity though. So going down, degrees of freedom. Well, our sample size here is 25, so I'll subtract 1 and write 24. And enter. So that t star is positive 2.06. And I guess we left 3 decimal places up on number 1, so I'll put 3 here, 2.064. Okay, let's do that the same way in part B. So again, I hit the second button and then the vars button to get to our distribution menu here. Go down to inverse t. And then we need to put on our area. For part B, we're looking at a 99% confidence interval, which means our tail area, which we got in the last part for a 99% confidence interval, was 0.005. So I'll put that in. 0.005. And the degrees of freedom in this problem is going to be 30 minus 1, or 29. And now I get 2.756. Okay. Let's go ahead and do some of these using the other method, because I know not all calculators have this inverse t option. So if you don't have the inverse t option on your calculator, they showed you in the study videos that you would go to the stat option here, go over to tests, and we can calculate a t interval, which is basically a confidence interval within the t distribution. But basically, in order to find our t star here, instead of actually calculating a confidence interval itself, we are going to calculate basically the interval for like a standard t distribution. So to do this, you go into data, not stats, or not data, stats, not data. And you're going to make your x bar equal to 0. So it's kind of like a standard t distribution. S sub x is going to be the square root of your sample size. In fact, I'll write this down. We're going to go, this is t interval with x bar equals 0. S sub x is going to equal the square root of n. And then everything else is pretty straightforward on this problem here. Oops, make sure you can see that. Okay, so x bar is 0. S sub x is going to be the square root of n. Our n here, our sample size is 35, so I'll put the square root of 35 for my s sub x. N, my sample size is 35, so I'll put 35 there. Notice when I move down, it automatically changes the square root of 35 to what the square root of 35 is equal to. And then confidence level, in this case, we want a 95% confidence level, so I'll leave that as 0.95 and hit calculate. And when I do that, it gives me the confidence interval that's centered at 0, okay? So this is one way. These are actually the t stars that give me that, that will give me any confidence interval with that sample size and that area. So this gave us, so again, we only need one of these two numbers. This is negative t star, this is positive t star. I'll just put my positive t star. T star is equal to 2.032. So you can see that? Yeah. Okay, let's do the same thing again for this next one. So I'm gonna go stat, over to tests, choose my option 8 t interval. And we're using stats here. When I'm using this to calculate a t star, we always make the x bar 0. The s sub x is the square root of n. This time our n is 50. And this time the confidence level is 90%. So I'll change this to 0.9. When I calculate, it'll give me my negative t star and my positive t star, 1.6766. So if I round to the nearest thousandth, like I've been doing all along, that's 1.677. Okay, one more time using this t-interval one. Stat, tests, option 8, t-interval, 0, square root of our sample size, which is 40 this time. Sample size is 40. And this last confidence level is 95%, so I'll put 0.95 and calculate. And there it is, negative t star, positive t star, 2.0227. 2.023 if I round to the nearest thousandth like I've been doing. Okay, so that's just calculating t stars, which is kind of like a standardized value. Now let's go ahead and use that to do some inferences. So in this first question, a supermarket wants to know how many people use the express checkout. In a single week, researchers record how many people use the express checkout during 10 separate 1-hour periods and come up with these totals: 54, 45, and so on to 50. Find a 95% confidence interval for the mean number of people who use the express checkout per hour. Okay, so I'm going to go ahead and use my calculator for this one. Okay, if I did not use my calculator, to do this by hand, I would need my t star. I would need the mean of this sample, so I'd have to add them all up and divide by 10. And I would need the S of this sample. So let's go ahead and just use our calculator this time. So the first thing I'm going to need to do in my calculator is I'm going to need to put all these numbers into one of the lists in my calculator. So I go Stat, Edit, clear out these lists real quick by highlighting the L and hitting Clear Enter. And I'll put in these numbers real fast: 54, 45, okay, so there's all 10 numbers. I know I have 10 because on this screen, it shows right there the little number 10 on my last one. I can scroll up and down to double check that I put them in correctly so I don't have a mistake. And now that I have that done, okay, I can go straight to calculating my confidence interval by using that same option that we used in our last problem. I hit the Stat, go over to Tests, and choose option 8, t-interval. And again, this z-interval option here will also give you the confidence intervals for a z distribution. And remember, we can only use z distributions if we know sigma, the standard deviation of our population. We don't know that here because we only have a sample, which is more realistic. So we're going to use t-interval. Okay, but again, your calculator can calculate that confidence interval with z's and with t's. Okay, we didn't use this option very much in the last unit, but you definitely can. So I'll hit Enter. And we have our stats already put in, we have our data already put into list 1. So rather than put in the stats, which I don't have calculated, I'm going to choose the data option and just tell it to get the data from list 1. That way I don't have to actually calculate X bar and S and all of that. Okay, the confidence level they ask for here is a 95% confidence level, so I'll leave that as 0.95 and hit calculate. And there it is. So let me write this down. So we did t-interval for L1 and a 95% confidence level. And it gave us this answer. Lower bound is 39.852. Upper bound is 49.348. Okay. On this next one, we have basically the same problem. They gave us some data and they asked for a confidence interval. Okay. So on this one, let's do this basically the same thing. I'm going to go Stat, edit my list. I'll clear this one out since I'm done with it and put in these numbers instead. 8, 12, 'kay, so there we go. I've got 9 numbers this time. It says 10. So at this point I have 9 numbers in here, but my problem says there's 10. So let's double check. Maybe I missed something. 8, 12, 5, 11, 10, 9, 3, 5, 7. Oh, there's a 6 at the end here. 6. There we go. Now I have 10 items in my list. Okay. So for this one, let's do it a little bit different. Maybe this question, it doesn't actually, but pretend this question asked you to give X bar and S and the T star that you used. If I go into my stat tests and choose that T interval option again, I can go over to stats and then put my data in here. So, but first I can go ahead and do stat, calculate. Remember, one var stats will give me those statistics very quickly. So I don't have to calculate them by hand. So I say one var stats, list one, calculate. There's my X bar. There's my S sub X. Of course, we already knew N, but those are the numbers that we need. So a lot of times they will kind of check to see if you know what you're doing by asking for those components as well. So I can write those down. X bar equals 7.6. S sub X, our standard error or standard deviation of our sample, is 2.9136. N is 10, which means our degrees of freedom is 9. Just subtract 1 from 10. Okay, so they don't ask for those specifically here, but we do technically need them to calculate this by hand. So now I can go ahead and just continue using my calculator. So I'll go over to test, choose option 8, and now I can choose data and use list 1 like I did in the last one, or I can choose stats here. And notice since I already calculated my one var stats in this calculator, it actually inputted those statistics into this this section here. So when we came in here before, this was all just zeros. Now that I asked my calculator to calculate one var stats for a list in my calculator, it stuck those statistics into this menu without me even telling it to. That's how smart your calculator is. So if they weren't in here, I would add those numbers in here. We want a 90% confidence interval this time though, so I'm going to change this 0.95 to a 0.90 and hit calculate. And there's our confidence interval. Notice it did not, the only thing that it didn't give you in this process was the T star. So we would still have to calculate the T star like we did in numbers 1 and 2 if that was something that was required for this problem. So our interval is from 5.911 to 9.289. So that again means that we are 90% confident that the true population mean is between these two numbers. Okay, next. A weight loss clinic wants to have an idea of how long it's taking its clients to reach their target weight. The researchers take a random sample of clients and record the following data in months: 12, 18, 6, 17, 25, 24, and so on. Find a 99% confidence interval for the mean number of months it takes a client of this weight loss clinic to reach their target weight. Give me 1 second. All right, so I know our calculator does all of this, but just for the practice here, let's go ahead and try to do this last question completely by hand without using my calculator. Okay, we're gonna have to use some methods that we learned back in the first unit of first semester, mainly how to calculate a mean and a standard deviation from a sample, which is all good to review because you should know how to do everything with and without a calculator anyways. So first of all, we know to calculate a 99% confidence interval, we always do, it's gonna be X bar plus or minus our T star times our standard deviation for our sampling distribution. Okay, so let's start by finding our T star for 99% confidence interval. With our sample size is, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Check it again. Does it say 15? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, 15 data points. So that means our degrees of freedom is 14. Okay, so I can grab out my table here, not using my calculator. If we're doing a 99% confidence interval, that means my tail area will be 0.005. Find the correct table here. So 0.005 is here. And it actually even says on the bottom here that corresponds to a 99% confidence interval. So 0.005. And our degrees of freedom is our sample size was 15, so subtract 1 to get 14, and they meet right here. So our t-star is going to be 2.977. 2.977. So that's my first thing, and I'll use a different color for this one. Okay, so that's one component I need to calculate my confidence interval. Okay, the next thing I need is X bar. Okay, again, our confidence interval is always X bar plus or minus T star times S over root N. Okay, so that's how we're going to calculate it by hand. So I've got my T star. Next thing I need is X bar. So to calculate the mean of a sample, I'm going to take all my data points, add them together, and divide by 15 because there's 15 data points. So I'll kind of abbreviate this. It's going to be 12 plus 18 plus yada, 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 all the way to 21 over our sample size is 15. So obviously, if I was going to truly do this by hand without a calculator at all, they probably would give us a much smaller sample. So to make things quicker, I'm going to pause and get that for you. All right, so that sum on the numerator is 259 over 15, which gives us an X bar of 17.2666 repeating. So 17.267 we'll say. Okay, so I got my T star, I got my X bar. I already have my N. N is the size of my sample, which was 15. There's 15 data points there. So the last thing I need is S. Okay, and the formula to calculate S is on your formula sheet here. S of X, the standard error or the standard deviation of your sample, is this equation here. In fact, there was what we just did to find the mean. We added up all the data points and divided by the sample size. Okay, so that's what we just did to find that last answer, 17.267. So now we're going to use this one to find our S of X by hand. Okay, so I'll put that to the side here so maybe you can still see it. There we go. And write this down. So the key things in here, remember this epsilon here means the sum of all of these. So we're going to put all these numbers in here, but then this part, we're going to do this data point minus X bar all squared for each data point and then add them all together here. So it's going to be a lot of work because there's 15 pieces here, but I can kind of show you in general what it's going to look like, and then I'll use my calculator off screen. So S sub X is going to equal the square root of, make sure you can see what I'm doing. All right, 1 over N minus 1, that's our degrees of freedom right there. 15 minus 1 is 14. Times, and I'll go ahead and just start doing the sum here. Times, so we're going to take each data point. So I'll start with data point here. 12 is my first one. Minus X bar, 17.267, parentheses squared. So I've got my first data point 12 minus the mean parentheses squared. And I'm going to do that for every data point and then add them all together. So I would write my next data point is 18 minus 17.267 all squared. And we continue that for every single data point. So actually we need to put a bracket there. I'm going to multiply it by this 1 over 14 after I've added all these together. So I'll do plus dot 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 and write my last one, which is the last data point is 21. So put 21 minus 17.267 all squared. Okay, for all 15 data points. Okay, so in your calculator order of operations, you would subtract in the parentheses for all of these data points, then square all of those differences, and then add all of those up, and then multiply that sum by 1 over 14, or divide that sum by 14, and then square root that product, and you'll get your answer, which is, I already have it here, because I did use my calculator. It's kind of a big sample to do by hand, honestly. So it will give you 6.2 6.204-ish. I rounded, 6.204-ish. Okay, so now I have my T star, I have my X bar, and I have my S sub X, which I calculated by hand, sort of. So now I can go ahead and calculate my confidence interval. So that is X bar, 2.977, plus and minus to get both boundaries. Our T star, whoops, I put the wrong number there. Way to go. And I don't have a whiteout. Okay, so X bar was this number, 17.267. There we go. Plus or minus T star, which is the 2.977. Whoops. Times the standard deviation of the sampling distribution for the means when we don't have the true population standard deviation is S, 6.204, divided by the square root of our sample size, which was 15. So I, order of operations, do 6.204 divided by the square root of 15, and then multiply that by 2.977. So 6.204 divided by the square root of 15 is 1.6018. That's our margin of error. Make sure you can see that. And then I'll subtract to get my lower bound, add to get my upper bound. Oops. 17.267 minus 1.602 is lower bound. 15.665 upper bound. 17.267 plus 1.602 is 18.869. Okay, so there it is, our 99% confidence interval for the true population mean of this T distribution. Okay, and now there is more on the back of this sheet. Let's see what it says. Oh, no, this is just data. We're all done. So if you have any questions, let me know.